It's Mr. Winchell. Just wanted to continue talking about linear factors of polynomials. I wanted to first review end behavior with you, just to go over that. The odd degree, meaning that the highest exponent is odd, 1, 3, 5, 7, 9. And if the highest coefficient next to that highest exponent is positive, then the end behavior is down, up. If it is negative, then it is up, down. If it is an even degree, then we come across these two situations. So the highest exponent being 2, 4, 6, 8, or then if A is positive, then they're both up. If A is negative, they're both down. So looking at this equation here and thinking about the answer of what does this polynomial look like, we are going after the end behavior, the y-intercept, and the x-intercept. Just like what we talked about yesterday with regards to shop week number 11. So I needed to look at the end behavior. So x times x times x, that's x cubed. So that's odd, and there's no negatives in front of it, so this is a positive a, so my end behavior is going to be down, then up. Okay. My y-intercept, I have a -1 times a -1 times a -2. So -1 times -1 is +1 times a -2 is equal to a -2. So that's my y-intercept. That's where the graph is going to cross the y-axis. And then I have my x-intercept. So that means, again, I have to take each piece, 4x minus 1, and set that equal to 0, 2x minus 1, set that equal to 0, 3x minus 2, set that equal to 0, and solve them. So +1 + 1, 4x is equal to 1. Remember your orders of operations when doing this, please. Okay, so add 1 over here. Now I have 2x is equal to 1. Divide by 2, divide by 2. X is going to be equal to 1/2. Add 2, 3x is equal to 2, divided by 3, divided by 3. X is equal to 2/3. So this is what I'm expecting. I'm expecting a graph that has a down and then an up for the end behavior. It's going to cross the y-axis at -2, and it's going to cross the x-axis at 1/4 or 0.25, 1/2 or at 0.5, and x is equal to 2/3 or 0.6667. So let's check that out. We get here, and here we have it. So here's our graph as best as I can get it to fit on this screen. It has down, up behavior like what we were talking about. It has a y-intercept of -2. It crosses the x-axis at 0.25, 0.5, and 2/3. So that's great. And hopefully that kind of helps refresh your mind with respect to shop week number 11 and the stuff that you had to do yesterday. So now what? And this is the point where you all get mad at me again and you're like, how can we do this? We're apart from each other. You're not here to help us through it. Well, we're going to take this piece by piece. We're going to do it slow, okay? And it's going to, we'll get there, all right? So I look at this and I can right away, I can go after my end behavior, right? I look at it, the highest exponent is 3. Good, so and it's positive, so that means my end behavior is down, then up. I go down here and I'm looking for this constant down here. Since there is no constant, that means my y-intercept is equal to 0. So see, we're already 2/3 of the way done. No problem. So I look at this and I say, all right, well, it's a lot. I need to, maybe there's a greatest common factor here. So I look, and as I'm looking, and we've talked about this before, that when I'm looking at for greatest common factor, I am looking for two things. Does every term have a letter, or does every term have a number? So those are the questions that I'm asking. Does every term have a letter? Yep. So that probably means my greatest common factor is going to be an x, or part of it. And this only has 1, so it's just going to be 1x. And then these numbers, they all have numbers, and they're all divisible by 2. So my greatest common factor here is going to be 2x. So I'm going to take, and I'm literally going to divide each term by 2x. So 2x cubed divided by 2x is x squared. 10x squared divided by 2x is 5x. And 12x divided by 2x is 6. So this is my factored form. And this is all going to be equal to 0 because I am, after all, going after the x-intercepts here. So I have to go through and now take and break this quadratic apart. Okay? So don't lose track of the 2x. We'll come back to this. So this is our box method, right? So down over here, we're going to have our box, right? And we have a times c, and the a times c is going to be 1 times 6, so that's 6. And we're going to have to find factors of b, or 6, that add up to 5. So I have 1 and 6. This is positive. So that'll be 6. I have negative 1 and negative 6, so that'll be also 6. I have negative 2 and negative 3. That'll be negative 5. And then I have 2 and 3, and that will be 5. So these are my factors. Okay? So I set this up, right? So remember, in our box, x squared, and you should have your notes available to you, pictures and stuff like that you took over the whiteboard before we left. And then these factors are going to go in here, 2x and 3x. So remember that the greatest common factor in this first row, that's x. Greatest common factor in this row, and that's 3. Greatest common factor in this column, that's x. And the greatest common factor in this column is 2. So that means, coming back up here, that this is going to split to x plus 2, x plus 3. That should look familiar to what we had in our shop week, where we have 3 linear terms. We can break that apart and to its pieces and solve, right? So 2x is equal to 0. I want to make sure I don't run out of camera here. X plus 2 is equal to 0, and x plus 3 is equal to 0. So x is going to be equal to 0 here, x is going to be equal to negative 2 here, and x is going to be equal to negative 3. So negative 2, 0, and negative 3. So that's the information that I need to take forward onto my graph, okay, which is going to be here, and it's not labeled or anything like that. So I know that I have a y-intercept at 0. I know that I have a x-intercept at negative 2. I also have an x-intercept at negative 3. And I know that my end behavior is down, then up. And I can just quickly sketch that. Okay? So that's the first example. All right? This is our second example. Okay? And I will take you through this one and then be able to work on the couple problems that I've assigned you for homework this evening. So again, end behavior, y-intercept, x-intercepts. Okay, my end behavior. I'm looking at this first term here. X cubed, so it's odd, positive, so that means my end behavior is down, then up. I look down here, I'm looking for my constant. That is a 0, right? We can always just kind of say, hey, there's a plus 0 there. So that's there, all right? And then my x-intercepts, now I have to go into that whole factoring thing, which makes us moan and groan. All right, so I'm looking at this, and the first thing I check for, because I always check for, because it's the first thing I always first check for, is the common factors, or greatest common factors. Does every term have a letter? Yes. Does every term have a number? Yes. So most likely I have a common factor. I just need to figure out what that is. So x cubed, x squared, x. So I'm going to go with an x here. 3, 3, and 36. Well, that's a common factor of 3. So let me divide each term by 3x. 3x cubed divided by 3x is x squared. 3x squared divided by 3x is x, so that's a negative. And 36x divided by 3x is a negative 12. There is my factored form, okay? And now I want to go after the linear factors of this quadratic right here, x squared minus x minus 12. So, set up our box, okay? A times C, so 1 times negative 12 is negative 12. Factors of negative 12 is got to be equal to negative 1. So I have negative 1, positive 12, 1 and 12, 2 and 1 and negative 12, 2 and negative 6, negative 2 and 6. I have negative 3 and 4, and 3 and negative 4. Okay? So this is going to give me 11, this is going to give me a negative 11, this is going to give me a negative 4, this is going to give me positive 4, this is going to give me 1, and this is going to give me negative 1. So there's our factors. Okay, so that means x squared here, negative 12 here, positive 3x here, negative 4x here. Remember, these two don't matter. These two have to be first and last. Okay, greatest common factor of the first row is going to be x. Greatest common factor of, column, excuse me. I'm doing it columns this way. Greatest common factor here is a 3. Greatest common factor of this row is an x. Greatest common factor of this row here is going to be our negative 4. So that means that this is going to break down to 3x times x plus 3, x minus 4. All right. Set each of those equal to 0. 3x is equal to 0. That's just x equals 0. X plus 3 equals 0. That'll be x equals negative 3. And x minus 4 equals 0. X equals 4. So I have x-intercepts of 0, negative 3. Wow, that's a horrible 3. And 4. All right. So I jump over to my graph. And I translate all that information. Okay. Sorry about that. We're still going here. So my M behavior, I have a y-intercept of 0. I have a x-intercept of negative 3. 1, 2, 3, 4. Make sure we're still on here. Okay. And down, then up. So here we go. All right. So there you have it. That's how you work with the greatest common factors. Factor that out. Break down your quadratic using the box method. And from there, we will then progress and push this a little bit further. So we are hoping that we will be able to take care of this and do well. There are a few problems attached to tonight's assignment to check your understanding on that. Remember, participation. I just want you to try them, do your best, and we'll go from there. Thanks. If you have any questions, reach out via Remind, let me know. Hope you're all safe and take care. Bye-bye.